Have you ever stared up at the night sky and asked yourself how on earth literally we managed to launch something the size of a small house into space, keep people alive inside it, and then bring it back safely to land on a runway? Not explosion, a runway. Today, we're diving into one of the boldest, loudest, and most ambitious machines ever built by humans. The Space Shuttle. A vehicle that was part rocket, part spaceship, part airplane, and unlike anything before or since. Stay with me, because by the end of this video, you'll understand why the Space Shuttle wasn't just a spacecraft. It was a revolution. Before the Space Shuttle, spaceflight was brutally simple and brutally wasteful. Rockets went up. One send, that was it. After every mission, most of the hardware was lost forever. Imagine flying to another country and throwing your airplane into the ocean when you land. That was normal. The Space Shuttle shattered that idea. NASA dreamed of a reusable space vehicle, something that could launch, work in orbit, and come back to fly again. The goal wasn't just visiting space, it was commuting there. This single idea unlocked everything that followed: building the International Space Station, repairing satellites in orbit, launching the Hubble Space Telescope, and running science experiments that changed what we know about the universe. Space was no longer a one-way trip. It became a workplace. Now, let's talk about Launch Day B, because this is where things get absolutely insane. On the launch pad, the Space Shuttle wasn't one vehicle, but a system. You had the orbit of their winged spacecraft astronauts actually flew. Attached to it was a massive orange external fuel tank, and strapped to the sides were two solid rocket boosters, each one taller than a skyscraper. When the countdown hit 0, all 5 engines ignited at once. The 3 main engines on the orbiter fired first. Then an instant later, the solid rocket boosters exploded to life. The ground shook. The sound hit you in the chest. Over 70% of the total thrust came from those boosters alone. In seconds, 4.5 million pounds of metal and fuel were climbing into the sky. In the first 60 seconds, the shuttle went from standing still to over 1,000 miles per hour. Inside the cockpit, astronauts were pushed back into their seats as the engines drank liquid hydrogen and liquid oxygen at a rate that bordered on the absurd. The external tank fed the orbiter non-stop while the boosters burned relentlessly, unable to be throttled or shut down. This was controlled chaos, engineered down to the millisecond. Just 2 minutes after liftoff, everything changed. The solid rocket boosters ran out of fuel. Explosive bolts fired, and suddenly, these massive cylinders detached from the shuttle and fell away, tumbling back toward Earth. But they weren't lost. Parachutes deployed, slowing them down before they splashed into the Atlantic Ocean. Recovery ships would later fish them out, tow them back, and prepare them to fly again. This was reuse in action long before it became a buzzword. With the boosters gone, the orbiter was lighter and faster. For the next 6.5 minutes, it continued accelerating, riding the power of its 3 main engines alone. By the time those engines shut down, the shuttle was traveling at 17,500 miles per hour, fast enough to circle the Earth every 90 minutes. At this point, the external tank had done its job. It separated and fell back into the atmosphere, burning up harmlessly over the ocean. The orbiter was finally alone in space. But reaching space isn't the same as staying there! To lock itself into a stable orbit, the shuttle fired its smaller orbital maneuvering system engines. This final push raised the lowest point of its path around Earth, keeping it from falling back down. And just like that, the Space Shuttle had arrived in Orbit's office for the next week or two. Up there, the shuttle transformed completely. The payload bay doors swung open, revealing a cavernous space capable of carrying cargo the size of a school bus. Opening those doors wasn't optional, it was critical. Radiators inside them dumped excess heat into space, preventing the orbiter from overheating. Missions ranged from deploying satellites to assembling the International Space Station piece by piece. Approaching the ISS required extreme precision. A slow-motion dance performed while both vehicles raced around Earth at thousands of miles per hour. Astronauts floated through the cabin, worked long shifts, exercised daily to keep their muscles from weakening, and gazed down at Earth, an impossibly thin blue line against the blackness of space. During spacewalks, astronauts exited the shuttle entirely, relying on bulky suits and the iconic Canadarm robotic arm to move equipment, install modules, and sometimes even reposition fellow crew members. Every movement mattered. Every mistake had consequences. Then came the hardest part of all, coming home. To begin the return, the shuttle turned tail first and fired its engines one last time. This deorbit burn was deceptively small but perfectly calculated. Slow down too little and you'd skip off the atmosphere like a stone on water. Too much and you'd burn up! Once the burn was complete, the shuttle flipped around, nose up, belly facing Earth, and began its descent. Re-entry was brutal. Slamming into the upper atmosphere at more than 25 times the speed of sound, the shuttle generated temperatures hotter than molten lava. Air molecules compressed and heated until the vehicle was wrapped in glowing plasma. For several long minutes, radio communication with Earth went completely silent. No calls, no updates. Just the crew, alone, riding a controlled firestorm. What saved them was one of the most advanced heat protection systems ever built. Thousands of black ceramic tiles covered the shuttle's underside, each one uniquely shaped, each one capable of surviving temperatures up to 2,300 degrees Fahrenheit. The nose and wing edges were made from reinforced carbon, built to endure even higher heat. These materials didn't absorb the heat, they rejected it, radiating it back into the atmosphere while keeping the interior cool enough to touch with bare hands. As the shuttle slowed, it stopped behaving like a spacecraft and started behaving like a very bad airplane. With no engines and no second chances, it descended as a 100-ton glider. The commander guided it through steep S-shaped turns, bleeding off speed while lining up with the runway. At the last moment, the nose lifted, the landing gear dropped, and the wheels hit the ground at over 200 miles per hour. A drag chute deployed, slowing the shuttle as it rolled to a stop. After days in space, the journey ended in silence. For 30 years, the space shuttle did the impossible, again and again. It was complex, risky, and unforgiving, but it built the foundation of modern space exploration. It assembled the International Space Station, repaired the Hubble telescope, and taught us how to live and work beyond Earth. Though the program has ended, its legacy is everywhere in today's spacecraft, in reusable rockets, and in the engineers and explorers it inspired. The space shuttle didn't just take us to space. It taught us how to come back. If you enjoyed this deep dive into one of the most extraordinary machines ever built, make sure to like this video and subscribe for more stories from the edge of science and space. And tell me in the comments, what's your favorite space shuttle mission? Thanks for watching, and I'll see you in the next journey beyond Earth.